All right, so in this practice, we are going to talk about 3.8, and so the learning target for this is I can write the equation of a line from a graph or table. So I've kind of really previewed this for you last week, but this is going to be the official lesson where we kind of talk about it. So I want to remind you of a couple things. First, that the equation of a line is represented by y equals mx plus b. So that is very important. You'll see that for the rest of your 8th grade math and next year and years beyond. So that's very important. And M just stands for slope, and the B stands for y-intercept. I don't know why they use those letters, but that's what those usually stand for and what they mean. So our job for each graph and table we look at is to find the slope, to find the intercept, and then kind of put it all together. So the slope is always the number that's next to x, and b is always the number that's added or subtracted onto that, okay? And so I talked a little bit last week about how last year you looked at equations with y equals kx. Those were when y-intercept, there had a y-intercept of 0, because those are lines that only go through 0, 0. So essentially, our b was always just 0, so you never really wrote it. This year, our b's can change. We might look at y-intercepts above the x-axis or below the x-axis, so that number will have to be added on, and so that's kind of why we're going to use a new general equation for that, which is y equals mx plus b. So I want to go through a couple examples so you know how to do it, and then you'll be able to complete the practice. So the first example, I want to look at a graph, okay? And so there's two things I need to identify to write an equation. I need to know what the slope is, and I need to know what that y-intercept is. So I'm going to kind of give myself a template to set it up so I can make sure to do both of those things. Slope is my rate of change, or how my line is changing. And so I talked about, to find this, to set up a table, because I have to find how my y's are changing, and then I have to divide it with how my x's are changing. So I'm going to create this table here, a little t-chart, and I'm going to put some points in my graph in the table. I'm going to choose that point, and I'm also going to choose this point. It looks like that's crossing nicely, or I could have chose this point, whatever works. So the point up on the left is -5, 4, and the point kind of in the center is 0, 1. So now I want to look at my changes in y values. So my y values are changing. They're decreasing by 3, and my x values are actually increasing by 5. So my change in y values are -3. My change in x values are 5. And so if I divided those, I would get a fraction, but I'm actually just going to leave it in this reduced fraction. And then the only other piece I have to find is my y-intercept, which is where my line crosses the y-axis. So if I look at my y-axis here, my line crosses right at that point, which is 0, 1. So when I put this all together, I have y equals my slope of -3/5 x, and then plus 1. And so that is my equation of this line. Okay, I could also write the same equation, 1 - 3/5 x. Either, those are the same. So either way will work. That's just kind of switching around using the commutative property. Okay, so that's how to do it kind of in a graph. And so now I'm going to show you on a table. So this table has x values and then outputs, or y values down here. So to find my equation of the line, I need the slope, which is the change in y over change in x, and I need the y-intercept. And in tables, the y-intercept is when x is 0. I need to find what that y value is. So this table, you can clearly see that it's not in there, so I have to do some work to find it. So first, let me find my slope. So to find my slope, I'm going to see how my y values are changing. So these are increasing by 16. This is by 8. This is by 12. This is by 3. This is by 4. And this is by 2. So if you look, this is kind of weird because the slope doesn't really look the same, but I don't want to just rule it out that it's not linear, because I want to check to see if my changes are the same. So my first change in y over change in x is 12 divided by 3. My second one is 16 over 4, and my third one is 8 over 2. And if you look, 12 divided by 3 is 4. 16 divided by 4 is 4. And 8 divided by 2 is 4 as well. So my slope in this case is 4, even though it didn't look like it was a linear table. It's actually 4 when I divide out all those changes. So my slope is 4. Okay, changing y divided by x. Now I have to find my y-intercept. So if I look, I always try to find where my 0 would go because I want to know when x is 0. So if you look, 0 is actually going to fall right in the middle of those two numbers. So instead, the difference between -2 and 2 would be 2. So that means if I'm going up by 2 on my y's, I'm going up by 8. So this is actually going to be 0, 2. So my y-intercept for this table is 0. So when I write my equation, I could write y equals 4x plus 0, or you can write y equals 4x. And that's how you can tell the equation of a line from a table. This one was kind of a tricky table in the fact that we weren't given the y-intercept, and the slope looked a little funky, but in the other ones, the table should be relatively easy. You should be able to spot 0 for your x, and some of them you might have to find. So that is writing equations of a line from a graph and a table.